Hi everyone, welcome back to the channel. Today let's discuss an interesting problem, that is Subarray Sum Equals K. Okay, let's start it by reading the problem statement. Given an array of integers nums and an integer k, return the total number of subarrays whose sum is equals to k. That is subarrays whose sum is k. Okay, initially what is a subarray? If we consider an array of elements, subarray is a part of an array that is continuous. There should be no breaks in it. It can be a single number, it can be a block of 2, a block of 3, a block of 4. But that block should be continuous. There should not be any breaks. That is, considering one element from here, another from here, this is not allowed. It should be continuous, right? It can be anywhere. Okay, this is one thing to note in mind. Okay, so let's consider one example. Let us see 1 1 1, and we need a sum of elements as 2, right? Okay, so you can see here, right, the the numbers 1 comma 1 here form a summation of 2, 1 comma 1 here form a summation of 2, but we cannot take one from here and here, right, as these are breaking. So it should be continuous. So 1 comma 1 and 1 comma 1 from indices 0 1 and 1 2, these are our two required solutions. Here the count will be 2, that is these should be continuous. So you can see that the indices are continuous, right? 0 comma 1 and 1 comma 2. Okay, similarly you can see an example 1 2 3 and a target of 3. Here you can see 1 comma 2 forms a summation of 3 and 3 forms a summation of 3. It can be a single digit, single number, it can be a block of 2, block of 3, block of 4, anything, right? So here you also you can see that the summation, that is the number of possibilities, as 2. That is, if we consider, let us say these are the elements in an array. If we consider, suppose there are indices I, suppose it is at index I and index j, we have to find the number of indices I comma j that satisfy the sum of elements from I to j gives a sum of k. We need to find the number of indices that satisfy this particular condition, right? That is, okay, now how to do it? What comes to your mind? That is, we are considering every possibility of pairing of indices, right? That is, if we take I here, j can take possibilities from here to here, right? That is, if there can be a subarray from I here to here, here to here, 0 to 3, 0 to 4, 0 to 5, 0 to 6. Again, 1 to 2 is another subarray, 1 to 3, 1 to 4, 1 to 5, 1 to 6. Similarly, 2 to 3, 2 to 4, 2 to 5, 2 to 6. That is, for every index of I, there can be a total of that is the next, from the next element we can form the subarrays, right, starting with I. That is, for I equals to 0, j can have values from 1 to n minus 1. That is everything that I comma j. Okay, j can be from 0 to n minus 1, right? That is, single element is also subarray, na? So I comma j. So yeah, so that is for I 0 to n minus 1, that is it can take any value, na? 0 to n minus 1. J can also take any value, right? That is, if I starts here, j can start from here to n minus 1. That is, I comma j means this one, right? 0 comma 0, that is a single element is also a subarray. A two elements is also a subarray. That is, 0 to 1 is a subarray, 0 to 2 is a subarray, 0 to 3 is a subarray, and so on. Similarly, 1 to 2, 1 to 3. Okay, so we need to find the sum of these numbers. That is, let us have a variable, that is sum. We need to run a loop from I to j. both are included, we need to add these numbers, num of k. If these sum is equals to the target, then we can say, then we can increase the count, right? That is c is the count, that is number of possible pairs. This means that the numbers from I to j that is included, that is num of I plus num of I plus 1 plus and so on plus num of j is equals to k, right? You can see here na? You can see here na? Yeah. Okay. Here we are running up to 3 loops na? 3 loops, that is we can have a that is time complexity of nq. Okay, is there any way we can do it in a better manner? Here what we are doing here, we are considering I is from 0 to n minus 1, j is from 0 to n minus 1, and you can see here k is going from I to j, right? Rather than doing it every time, we can minimize this one, right? So let's keep it this way, that is for I is going from 0 to n minus 1, right? Let us have a variable sum that is 0. For j is equals to I to n minus 1, we can add the sum num of j. But here we need, see here what we are doing is we are considering 0, we are considering j is also 0 for initial statement, that is k runs from 0 to 0. We will have a sum calculated. Again I will be 0 and j will be 1, j goes to 1. Again k goes from 0 to 1, right? Again 0 to 2, k goes from 0 to 2, that is we are again adding indices at 0 plus 1 plus 2, right? We are already having 0 plus 1 value here na? So why should we do again the same thing repeatedly? So to eliminate that, we will declare a variable here, that is we are continuously adding the elements and continuously checking whether we have reached a particular target or not. So if here the sum is equals to target, then we can increase the count, right? So we can return the count here. Here you can see na, again 0 0 to 0, 0 to 1. Here let us say let us consider an example 1 comma 1 comma 1. Okay, initially I is at 0, j runs from 0 to 0 1 2, right? Initially s is 0. Again at j equals to 0, at j equals to 0 s becomes 1. Again at, we will check if s is equal to the target is c, right? If s is equal to target, no. Again j goes forward, j goes to 1, s will become 1 plus 1, that is initially s has 1 and the new number is 1, it will become 2. Is it equal to target? No, it's not equal to target. Again move forward, s will becomes 2 plus 1, that is 3. Yes, it become target, so we will increase the count. So here we are reducing a loop, right? That is we are not doing the same thing repeatedly, so we are minimizing the time complexity. Here we will get a time complexity of O of n square, as we are having two for loops running from 0 to n minus 1. Okay, now comes the interesting part. Now let's try to do it in an much optimized way. This comes under a tag of PrefixSum. This is a very important topic. Please be familiar with this one. These interview questions are mostly asked in FANG. So I will also try to make in-depth explanation of this. Now let's brief it. Let us say there are some elements in an array. Here we need to find subarrays, right? We need to find subarrays. That means these subarrays are continuous, right? So what PrefixSum says is, we will rather than going through the array multiple times, at one time only we will try to store the PrefixSum, that is sum of elements from starting index to that particular index. Let us see how it will be useful. Okay, let us say Let us consider this index and this index. Suppose we need to have a target of, let us say, tar. Let us say we have a target tar here, right? And the total sum from initial index to this index is s1, and summation from initial index to this index is s2. Then tar is s1 minus s2, right? We use this concept here. That is, from initial index if we have the summation of s2, from initial index we have summation of s1, then we can say we will have a summation of tar here if we have a summation of s2 from initial index to here as s2 and total sum as s1, then we will have tar, right? So this will be much more clear here. See, these are the elements, right? This is a particular index. So what at this particular index, if we want a subarray of some sub that ends at here, subarray of some sub that ends at a particular index, that subarray can be of size 1, can be of size 2 if it is possible, it can be of any size, right? But the sum is sub only, right? The total sum in this one is sub, the total sum in this one is sub. It is possible. See, if we have elements 2 comma 3 in this one, then the sum is 5, right? That is, we have 2 comma 3 here also. If we have minus 1 comma 1, then the total sum is minus 1 plus 2 plus 3, it is also 5. Then the total sum, it is also 5. So this is also possible, right? So if the total sum is yes and this particular sum is sub, this sum is sub, then the sum from here to here is s minus sub, right? Similarly, from here to here is also s minus sub only, na? As you know, from here to here is sub and from here to here is s1, then this one will be s minus sub. Similarly here to here is sub, the total is s, then this one will also be s minus sub. So what we can say is the number of ways we can have a subarray, the number of ways of having a subarray of some sub ending at a particular index is equals to number of ways of the number of possible prefix sums value of total sum is s1, right? S minus this particular sum is sub, right? Sub. That is, from initial index to here is s, we need to find a value of sub. It can be of this side, this size, or this size, or even the full, right? That is, if we have the number of ways we have s minus sub, this one is s minus sub, this one is s minus sub, this is s minus sub. So if we have 4 of this kind, then we can say there is 4 of this kind, right? If we have 4 red circles, I am representing as red circles whose sum is s minus sub, then there will be 4 blue circles, right, whose sum is sub. So this is the concept we use here. Got it, right? So that is, how can we achieve this? Think of it. That is, suppose we are at a particular index, we need to store the values. That is, we need to store how many times a particular sum is occurring, right? That is starting from this particular index, right? So we can use a map of key as sum from the starting index and the value as number of times it occurred. That is, I hope you got it. Let us say the total sum is 8. Okay, we need to find subarrays of sum 5 ending at this index. Then this implies number of ways of having subarray of size of sum 3 in this interval, that starting at this index, that is if it is 3 we can take it, if it is 3 we can take it, if it is 3 we can take it, right? This is 3 means this is 5, right? This is 3 means this is 5, this is 5. So this is the concept we use here. So for this we will use a map, that is in the map we will have as m of 3 is 3, that is we have seen subarrays of sum 3 starting at the initial index 3 times, and 3 times, that is 3 3 3, right? Okay, now let's try to write a pseudocode for this. We need to have a map, right? Map int comma int m. So initially there is no, we don't have any sum, right? That is we are having 0. This is also a possible case, right? M of 0 is 1, that is we haven't taken any number into consideration, that is we have a sum of 0, right? So for int I equal to 0, I less than n, I plus plus, let us take a variable as sum is equal to 0, then s is equal to s plus num of I, that is we are here, we are in the first array. If m dot find s minus target not equal to m dot n, then count will be count plus m of s minus target, right? You have seen here we need to find a target of 5. This implies number of ways of having a subarray of sum 3 starting from the initial index. This is the one. Here the target is 3. The total sum until that particular index. S is the total sum. S implies total sum till I. So this is the number of times we have seen the number 3. Okay, hope you got it. Then we need to return C, and every time we need to increase the value of S, that is if we have seen 3 once, then m of 3 will be 1, again minus 1 1, 3 plus minus 1 plus 1 is again 3, then m of 3 will be 2, then m of 3 will be 3, if you again see here, right? This is how we will proceed. Now it will be good if we dry run it. So let us try to have a example. Let us take an example 1 2 3 minus 3 1 1 1. Okay, initially we are moving from here to here, right? Initially the s is 0, then then in the map we have the map, right? In the map we have 0 and we have seen it once. Okay, now we are moving. Let us take a target as 3. Okay, now here the sum will be 1, right? Here sum will be 1. Did we have minus 2 in the map? No, we don't have minus 2, right? If we have minus 2 we can increase the count, that is if we have not minus 2, sorry, it's 2. If we have 2 in the map, then we can increase, that is we have 2 and we have 1, 2 plus 1 is 3, right? Then we will find the target, but we did not have any 2 right here, so we cannot say that. Then the sum is 1, we haven't seen sum 1, right? So we need to store it in the map. Move forward. Here the sum is 3. See, here the sum is 3, right? In the map, do we have the value of 0, that is sum minus target? Do we have them, that is 1 comma 2, the sum is 3, right? Here we have 0, initially we have 0, right? 0, that is assume there is a subarray of sum till here is 0 and the total sum here will be 3. right? Then we can say that there exists a subarray of size 3 here, right? This small particular part, this is the entire part, this is the before part from the starting index, and this is the remaining part, right, till this index. So there is so there exists one. So what we can say is we need to set the 3 as 1, and we need to increase the count becomes 1 right here. Now again move forward, s will become 6, that is 1 2 3 3 till here the sum is 1, till here the sum is 3, till here the sum is 6, until here the sum is 9. Now we are here, so s is 6, right? So until here we have 6. In the map we have 3, right? In the map we have sum minus target is 3. In the map we have 3. That means here to here is 3, here to here is 6. That implies this small particular part is 3, right? That is there exists a subarray of size 1 like this, that is of summation 3, right? So we need to again increase the count. So now move forward. No, the summation is 6, right? Summation is 6, so we need to include a value of 6 here. Now move forward, then it will be minus 3. Then the total sum will be 6 minus 3, that is 3. That is 1 2 3 minus 3. Here to here is 1, here to here is 3, here to here is 6, here to here is 3. So here is 3, right? Do we have s minus target, that is 0 in the map? Yes, we have 0 in the map. That is this total subarray sum will be 3, right? 1 plus 2 plus 3 plus minus 3 is 3, right? So yeah, we have seen it. But the total subarray sum from starting index to here is 3, right? We need to increase the count of 3 to 2. Now this becomes 2. Now again move forward, the sum will be 1 2 3 minus 3 and 1. Now here to here is 3, then here to here will be 4, right? Do we have 4 minus 3 1 in the map? Yes, we have 1 here. Here we have 1, right? There is 1 in the map. That means there exists a subarray here also. So again here the total subarray sum is 4, right? We need to include 4 here, and we need to increase the count. So in this way we will go till the end, right? Got it, right? We are finding, see, we have the total sum till the index, we have subarray parts from starting index in the map stored, right? So at this particular index, if you want to find target of a particular, let's say tar, then this is similar to finding number of ways of subarray starting from starting index of having value sum minus star. Yeah, hope you got it. Now let's do the coding part. So we need to have a map, right? It's the declaration of the map. So we need to have two variables, one for the sum and one for the count. Initially we need to have 0 in the map, right? If we don't have any values, then the sum is 0. So we have found it once, right? M of 0 equal to 1 means there exists a sum 0 and it had occurred once, right? So we need to run through the loop. I less than nums dot size I plus plus, the sum is equals to nums of I. So if we find sum minus k already present in the map, then we can increase the count by number of times it's found, right? And we need to increase the frequency of the sum prefix sum, right? Here s represents the prefix sum, so then we can return C. I think this is it. This is the logic behind it is more, but the code is less, right? The intuition behind it is more. So yeah, we have submitted it. You can see all test cases are passed. So this is a very important topic, so please make sure that you have understood it. Yeah, thank you. If you find this content helpful, please support my channel, and if you have any particular questions you need to work with, please comment it in the comment section. I will be more than happy to help you out, guys. Yeah, thank you.